In this section, we're going to take a look at how you can combine functions using what is known as the composition of two functions. Then we'll also take a little bit of time to basically view things backwards by taking one function and kind of figuring out what two functions it came from when we used the composition. The basic idea for the composition of two functions is that we'll be taking one function and actually putting it inside of the other one. A good visualization that you can imagine for this is imagining the Russian nesting dolls. How one of the smaller dolls fits inside one of the larger ones. And then you can fit that one inside another one, and so on and so forth. So we'll basically be doing the same thing with functions. We'll be taking one function and using it as the input into another function. The notation you'll see for this looks a little bit like this. It says that I have f of g of x. And notice how rather than just having an x inside of that f, that there's an entirely new function g inside of there. So g here is being used as the input into f. Now, just like with all of the other operations we've seen so far, this again has two different notations. Here's the alternate one. This one also says f of g of x. Now, when it's written like this, notice how the one closest to x, in this case g, will be the one on the inside. Now be careful. That circle there makes it look like you're multiplying functions together, but you are not multiplying them. For the composition, use an open circle, and it means to take g and put it inside of f. Now this has a huge effect on the domain. For the domain, we want to imagine the set of all x's in the domain of g, such that g of x is in the domain of f of x. To really imagine how this is going to work, you really need to think about the inputs and the outputs of both of them. And I'm going to do this with a quick example. So imagine I have two functions like h of x, which is the square root of 3 minus x, and k of x, which is 1 over x. And I'm going to record the domain and range for each of these. Now, when I make the composition of these two functions, say, for example, I put h inside of k, I get this new expression 1 over the square root of 3 minus x. Now, to figure out what the domain of this one will be, well, I need to check the domain and range of each of them and to see if there are any conflicts. So first I begin with my inside function h. So notice how it takes any values between negative infinity and 3. This is because we don't want a negative sign underneath the root. And it produces an output between 0 and infinity. Now since h is inside of k, those outputs then become the new inputs for k. Okay, so k takes any number except for 0, because we can't divide by 0, and it produces any number except for 0. So essentially we have a little bit of a problem. It looks like h can produce 0, but k does not have 0 in its domain. To see why this might be a problem, let's start at the very beginning. So suppose I use 3 into h. Well, I'd get 3 minus 3, which would be 0, and the square root of 0 would be 0. That 0 would be used as the new input into k. And I can't do that. It created division. So essentially, I want to throw that 3 out of my domain. So for this new function I've created, I could use anything between negative infinity and 3. To get a better idea of the composition of two functions, we're going to go through a few different examples. In this first one, I have f of x equals 3x minus 1, and g of x equals x squared plus x minus 3. And right now, I want to find f of g of x. Now remember, when it's written like this, g is essentially the inside function, and f is the outside function. So in order to evaluate this out, I need to do a few replacements. So I'm going to replace g of x on the inside with what it is equal to, so the x squared plus x minus 3. And notice how that all becomes my new input for f. So in the next step, I look at f, and I'm going to replace each of its x's with x squared plus x minus 3. There we go. Now, I do have to do a little bit of simplifying from here, such as distributing that 3, but essentially it does give me a new function when I'm all done. So this says when I take f of g of x, that my new function is 3x squared plus 3x minus 10. Now let's do a very similar example, but with one little twist. you'll notice that I'm still using the same functions f and g. Only this time, I'm going to look for g of f of x. This means that I want to put f on the inside and g on the outside. Alright, so let's go through this process. So with f on the inside of g, I first need to go through and replace f of x with its expression, so the 3x minus 1. Now I have g of 3x minus 1. So that inside part will now be used as my new input into g. So I'm basically going to look at g and replace all of its x's with a 3x minus 1. And since g has two x's in it, I have to replace both of them with the 3x minus 1. Now this one definitely does take a lot of simplifying. I have to square out the 3x minus 1 on the left, and then probably start combining a lot of my like terms. So I have a minus 6x and I have to add it to a 3x. Well, that's not too bad. Now, notice how when I'm all done, I get a 9x squared minus 3x minus 3. And that represents when g is on the outside and f is on the inside. And the only difference between this example and the other one is I've switched which function is on the inside and which is on the outside. But it created an entirely different result. So you really have to be careful the order at which you do composition. Now let's look at an example where we have some numbers for our inputs. So here I now have f of x equals the square root of x plus 1, and g of x equals x squared plus 4. And in the first part, I want to find f of g of 2. Remember, that means that g is our inside function and that f is on the outside. Well, as I start to go through this, let's start with the inside. This says I need to take 2 and use it as an input into g. So imagine taking g, plugging in a 2, and then evaluating it out. So 2 squared would be 4, plus another 4, looks like 8. So that would be the output that g produces. Now that output of 8 becomes the new input for f. And so I'd take that 8 and put it into our function f. So 8 plus 1, give us a 9, then take the square root, and I get an output of 3. So altogether what I have here is that when I put 2 into the composition of f of g, I get an output of 3. First, it essentially goes through g, the inside function, and then it passes through f, the outside function. Now remember that if you switch the order, you might get a different result. So let's give this guy a try. Here I have g on the outside and f on the inside, which means that the function that the 2 will go into first will be f. So imagine taking 2 plus 1 and then doing the square root. This will give us the square root of 3. And then that becomes the new input that we go ahead and we put into g. So I take the square root of 3 and I square it, I get 3, and add it to 4, and I get a 7. So altogether, this says that when I put 2 as my input into g of f, that I get an output of 7. Let's finally finish this up by doing one more example. So notice I'm using the same f and g as before, only this time I want to find g of f of negative 4. So what happens when I use negative 4 as an input? Now, immediately I'd start replacing things. So, put negative 4 in f. The only problem is, when I put a negative 4 into f, I get a negative underneath my root. Well, that's not in my domain then, essentially. Well, if negative 4 is not in my domain, what other things are not in the domain? What other values can I not use? Well, to get a real good sense of that, let's go ahead and record the domain and range of each of these functions. So the domain of f would be from negative 1 up to infinity, and the domain of g would be all real numbers. The range of f would be from 0 to infinity, and the range of g would be from 4 to infinity. So essentially, when I start using values, I'd first plug them into f. And according to its domain, I could use anything between negative 1 up to infinity, and it would produce values from 0 to infinity. Now, those values it produces would then get plugged into g. Unfortunately, g can handle anything. It can handle any number between negative infinity and infinity, and it would then produce values between 4 and infinity. So, looking at the range of f and the domain of g, it doesn't have any really conflicts or any real problems. Anything that f produces, g can handle. So, the overall domain, when I put them together, becomes the domain of f, the inside function. This is because when we start thinking of putting in inputs, it's first going to have to go through f. So first it must be in the domain of f. And then whatever values it produces, the range, as long as it doesn't have any conflicts with g, then we're okay. So the domain of g of f of x in this case would be the values from -1 all the way up to infinity. Now that we've spent a lot of time putting functions together using the composition, we also want to be able to think backwards through this process of, starting with one function and imagining what two functions were composed in order to make it. This is known as the decomposition of two functions. And here's a quick example. So here I have 3x plus 2, the whole thing squared, plus 5. And this was created by taking two functions and composing them, so putting one inside of the other. To figure out, which functions I used, I want to visually inspect this to see which function is on the inside and which one might be on the outside. Well, the way I look at this is when I see the 3x plus 2, it's like that little piece right there is my inside function. Now, what did I put it inside of if that is on the inside? Well, I put it inside of something squared with, a plus 5 added onto it. So what I could say is that my inside function, let's call it f, is 3x plus 2, and that I put that one inside of g of x, which is x squared plus 5. Now, take note that that was just my interpretation of what was on the inside and what was on the outside, and that you could actually have other answers for, say, what the inside function is and what the outside function is. You could have chosen, say, just a 3x for the inside, and that would have forced the outside function to be x plus 2 quantity squared plus 5. Let's do an example with this so you can see a little bit more about the decomposition. So here I have h of x equals 6 plus the square root of 3x minus 1. And I want to figure out what two functions I used on the inside and on the outside in order to create this. Well, one thing that you might interpret is maybe that 3x minus 1 is the inside function. And what was it plugged into? Well, it was plugged into 6 plus the square root of x. And one way you could really double check to see if, that really is my outside and inside function is to go ahead and compose the two together. So when you put g inside of f in this case, do you really get 6 plus the square root of 3x minus 1? And if you do, you know that these are good, valid functions for the inside and the outside. Now, of course, this isn't the only interpretation. You might imagine the inside function as just being the 3x. And if you use 3x as the inside function, then your outside function would be 6 plus the square root of x minus 1. Again, the way you could double check that this is a valid choice for the inside and outside function is to compose the two together. So when you put g inside of f, do you get 6 plus the square root of 3x minus 1? You'll find out that you do. So really, either of these interpretations for your inside and outside functions would be correct.